Okay, so are you guys there already?
Yes, sir.
Okay, so we'll just wait 1 minute for the others. Maybe they're still in bathroom or they're still doing something. All right, so let us now continue. Okay, so did you guys uh, get this one on how did we get the 16 ohms? So I would like
Yes,
you
sir.
guys to verify whether our answers is correct or no. In some cases, my answer is incorrect. So is our answer correct or no?
Tama, sir.
Tama.
Yes,
Correct?
sir. Tama.
Okay then. All right, so the following are just super easy. So for the letter B, so the total current. So as you guys all know, once you already have the total voltage and then the total resistance, then you're good to go. Okay. So I is equal to V divided by R. So V here is 40 volts, right here, E. Okay. And divided by 16 is your total resistance. So 48 divided by 16 is 3 amps. So this is our total current. Okay. And for the letter C, the voltage drop across each section. Okay, so take note each section. So this is your first section, second, and then third. So if it asks us to get the uh, current on each resistor, then that is a different thing again. But in here, three sections only. All right, so here's the first section. So as you guys can see, we have here the voltage of the first one and then the voltage of the second one. So how did we get this one? So by using the I times R. Okay, or you can just simply actually combine those two first, like getting the value of this one. So your I is 3. So 3 times 4 is 12. Okay, so in that way, it's a lot easier to do. Okay, so we already have the first section, second section, and then third section. So we have the formula EIR. So just get the total current, which is 3. So 3 times 4 is 12. And then 3 times 3 is 9 volts. And then 3 times 9 is 27 volts. All right. So did you guys get this one? And how did we get the voltage on each or on every section?
Yes, sir.
Yes, sir.
All right. And then one more thing for you to check whether your answers is really correct or no. So if you add all of those, okay, E1, E2, and then E3, you should get the total voltage. Okay, so E total is equal to E1 plus E2 plus E3. Okay, so you should have 48 volts once you've added those three. Okay, so 12 plus 9 is 21, and then 21 plus 27 is 48. Okay, so in that case, we verified that our answer is correct. All right, so moving on, we have here the letter D. So what is letter D? The current through each resistor. Okay, so in here we have to get the current of R1, R2, R3, R4, R5, and then R6. So here's your R1, I guess, I6, I6, I12, I3, 6, 12, 3, 6, 12, 3, 15, 19. Yeah, so they are arranged from R1 to R6. So your I6 here is your R1, I12 here is your R2, I3 here is your R3, and so on and so forth. So just get the total voltage divided by the individual resistance, which is 6, 12, 3, 15, 90, and then 30. Okay, and then you will get the corresponding current, okay, or the individual currents. So for R1, we have 2 amps, R2, we have 1 amp, R3 is 3 amp, R4 is 1.8, 0.3, and then 0.9. And then another thing here is if you added all of those, you should get the total current, okay, which is 3 amp. I guess no. Okay, since we have series circuit, if we have a pure parallel, then that's possible. So in here we have one series, so that is not one way to check our answer whether this one is correct or not.
But I think if we add each section, it will give us 33.
Yeah.
Section
We
one.
will get
Yeah.
3. So for one
Yes.
this section is 3 amps, and then this section is 3 amps. So as you guys can see, how did that happen? Because we already combined this one, making this one as a series connection, and then another series here, and then another series here. So in that case, I total is equal in every section or in every component of your circuit. Okay. So yeah, that is one way to check. So 3 amps, and then if you add these 3 amps also. Okay. So are we clear with this one? Can you guys follow?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So if we're confused, like if you need, like there are some people who needs an image or who needs this circuit or schematic diagram while answering. Well, I really am so sorry because I wasn't able to put it right here. So yeah, we still have space here and then another space here for you to, just to keep on looking on that one, that this one is parallel one, this one is a series one, etc., etc. Just for you to verify whether your solutions is correct or not. Anyway, this one are super easy anyway. So I guess you don't need to follow it by the diagram. Anyway, for the last one, the total power taken by the entire circuit. Okay, so in that case, just use this formula. Oops, here. So P is equal to E times I. So E here is your total voltage, and then I here is your total current. So E is 48 times 3, which is your current. So you will get 144 watts. Okay, so this is the total power consumed by this circuit. All right, so it's easy, right? It's just that there's a lot of questions, but this one is super easy to understand as long as you know the formula. Okay, so yeah, that's it for the example. So I would like you guys to answer this one also. So you have your assignment number 1 already, and then I'm giving this one as your exercise number 1. Okay, so here's the circuit. So we have here the values of your E up to R6, and then we have here the questions, which is, I think, the same, okay, with the past example. So calculate the total resistance, total current, the voltage drop across each section. So we have 3 sections right here. And then, excuse me, the current through each resistor. So I should see 6 individual current. Okay, and then the total power taken by the entire circuit. Okay, so again, you guys can do this one on Microsoft Word. Okay, and if you cannot do it on Microsoft Word, you can do this one via handwritten. Okay, but then again, if you're going to do this one handwritten, please write legibly. All right. Are we clear so far?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so I just received the message. Sir, saan po i-upload yung assignment at activity number 1? Okay, so actually it's already in here. Where is that one? Okay, it is already in here, your example number 8, assignment number 1, and exercise number 1. It's just that I haven't published it yet since I haven't finalized it yet. Okay, so I will include here blanks wherein you're going to put your final answer, and then for your solutions I will put another question wherein you can upload the solution. Okay, so the same with your quiz. So later on I'll show this one to you guys, but for now we'll just finish our discussion on module 2. Oops. All right. Okay, so that's it for your exercise number 1. So let us now talk about sources of supply. Oops. Yeah, sources of supply in series are parallel. So it is sometimes necessary to connect 2 or more sources of supply in series or parallel to deliver power to 1 or more loads. Okay. When this is done, it is desirable and often imperative. Okay, so when it's imperative, this one is crucial in real life. Okay. So in diagrams, so nothing will happen, okay, especially if you have incorrect polarities. But in real life, this one is very crucial. So it might explode, okay, or your house might get burned. So just be careful when using 2 individual sources, okay. The individual sources such as batteries, generators, or both be exactly similar. Okay, so they should be exactly similar. So if we have, let's say, 20 volts on the first source, then you must also have another 20 volts on this source. Because if, let's say, you have 20 and then 10 here, so that is not a good combination of 2 voltage source. Okay. So the current or the fluctuation of your current might not be this one might not be able to sustain, or there might be a collision, okay, wherein they don't have the same amplitude. Okay, so that is one thing that you guys need to consider. And then this implies that the terminal voltages of the individual sources are equal to one another. Okay, so not just the voltage itself, okay, but the terminal voltages of the individual sources. Okay, so let's say, yes, you are providing 5 volts and then 10 volts here, but they have different terminal voltages, wherein there's a big chance that this, let's say, bigger terminal voltage, or yeah, let's see, they're different with each other, a bigger and then smaller. So there's a chance that this one will fluctuate, and then there's a chance that this one will also fluctuate. And then when that happens, so you don't know on what is the voltage that it will throw to your component or to your circuit. Okay? So in the case of batteries, that the resistance inside the several units, so the resistance of internal chemical substances are equal. So in terms of batteries, okay, let's say you have 2 batteries, say batteries of motorcycle, you want to combine 2 batteries at the same time. It's not just enough that they have the same voltage output. Okay, possible to the same brand, to the same internal parts, especially the resistances part, okay, to just to make it really, really consistent, and you know they are going to jive with each other. Because if 2 different brands, let's say, yes, the same voltage output, but two different brands that might not do good. Okay, so that might still damage your motorcycle. All right. So the ladder designated internal resistance is usually quite small in comparison with the main circuit, and although often neglected in computation involving single batteries, must generally be taken into account when several such sources are used. So if it's just one source, it's okay to have as many internal resistance as you want, but when it comes to two individual sources, then you must have the same. Okay. So yeah, that's it for one voltage source and then two voltage source. So in computing voltage source, so this one is actually super simple. Let me just give you an example right here. So for example, you have this circuit, positive, negative, and then we have another positive, negative right here. So in circuit diagram, so you could have two flow, okay, or two types of flow. So you can have the clockwise format or the counterclockwise format. But mostly the one that I use is the clockwise format right here. So in that case, just know the symbols. We have here negative and positive, right? Then we have here negative and then positive. So let's say this voltage source is 5 volts and then another voltage source here, let's say 7 volts. Okay. So they will just simply add that with each other. Okay. So we have here positive 5 plus positive 7. So how did I get this positive? So I always base my sign on the let's say last symbol or last this one polarity. Okay, last polarity of my component. So in here, the polarity of this one is negative and then positive. So it will go out to positive, and the same with this one, it will go out on the positive. So that is why I have this this one signage, okay, positive signage. So plus 5 and then plus 7, of course, it will give you 12 volts. So you can just simply combine them into one voltage source. Okay, just like that. But if you have two different polarities of let's say voltage source, like for example, this one is nabura din lahat. Okay, let's say we have positive here and the negative, and then we have here positive and then negative. Okay, so let's say this one is still 5 volts and then this one is 7 volts. So again, we have this polarity. So as you guys can see, we have here positive 5. So I am basing it on the where it's going out. Yeah, we're going out with our voltage source. So in here, it will go out on the negative sign. So we'll have here plus minus 7. Okay, so in that case, you'll have here a voltage or a total voltage source of negative 2 volts. All right. So are you guys able to follow if you have two different voltage source?
Yes, sir.
Yes, sir.
Okay, so just take note the polarity. Okay, so that is the important part when it comes to having a lot of voltage source. All right, so we have here the series rules connection. So for the current, so the total current is equal on all of the components. Okay, like for example, you have 2 components or up to 10 components, or up to infinity. So you can have as many as you want. So I total is equal to the I1, I2, I3, I4, etc., etc. Okay, so that is in current, I mean in series connection. Okay, and then for the resistance, so you have to add everything. Okay, R1 up to let's say Rn is equal to your R total. All right. So these are already your cheat code when it comes to computing the current and then resistance. And then for the parallel, okay, so for the voltage, so as you guys may all know, this is one of the basics of parallel. So E total is equal to, let's say, this section, and then another section, and then another section. So in every section, we are with the same voltage. So E total is equal to E1, E2, etc., etc. Okay, and then for resistance, so this is how you compute the R total. Okay, so this one is in pure parallel only. Okay, so let's say you have 5 resistance, so you will use this formula. Okay, if you have 5 resistance which is parallel with each other, but if you only have 2 parallel resistance, then you can use this one instead. Okay, R1 times R2 divided by R1 plus R2. All right. So that's how you compute for the R total. And then for the current, so we have to add everything in here. So in series, they are equal with each other, but in current, your current will be divided on every section. So let's say you have 3 sections, so I1 plus I2 plus I3 is equal to your I total. Okay. So yeah, that's it for the rules when it comes to computing the series and parallel connection. So are we clear so far regarding with this one?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So
So
since we are not in the combination of series and parallel yet, so your quiz will focus on every single topic. Yeah, every single topic. Like if the question is only about series, then that one is only for series. If the question is for parallel, then that one is only for parallel. Okay, so to avoid confusion. So for the quiz number 1, so here are your foundation. Okay. So you can use this one for the series, then you can use this one for the current. Okay. So that's it for now for the module 2. So later on, we'll be adding more topics regarding with series parallel and then parallel series, which will be discussed next week. Okay, so that's the combinational. Okay, and I would like you guys to answer this one also. So I created a practice exercise. So this one is quite simple. Okay, so as you guys can see, it's only asking the E sub 1, E sub 2, E sub 3, power 1, 2, 3, etc., etc. So this one is fill in the blanks. Okay, so I included already here the instruction on how to answer this one. Like for example, you have this answer. So or 5.26666, then just make that one 5.27. Okay, so up to 2 decimals only. And yeah. So yeah, just about identifying which of these circuits is a CLS circuit, and then you have here the choices. And then we have here some situational, wherein what would happen if 3 6-volt light bulbs were connected as shown to a 6-volt battery. So just choose your answer here. And more questions about series, right? So check this one. The due date of this one is March 5. Okay. So this one is also a total of 70 points. And then for your quiz, for the module 1 and 2. So this one is actually a total of 126 points. Okay, so don't get shocked. Okay, the points is high, but the difficulties of this quiz is super easy. Okay. So it's like everything is a bonus. All right. So as you guys can see right here, we have here a circuit, and then we have here the questions. Determine the equivalent resistance, the current from the power supply, the current through each resistor, voltage drop across each resistor, the power dissipated in each resistor. So very similar with our examples. Okay, so this one is in series. So here are the given, and then here are the things that you need to answer. Okay, so I've already put here the items that you need to answer. Right? So from R total to P3. And etc. etc. So in here, I've included this one because I would like you guys to draw the schematic diagram. So a kitchen in Cambodia has 3 appliances connected to 120 volts circuit with a 15 amp circuit breaker and 850 watts coffee maker and a 1200 watts microwave oven and a 900 watts toaster. So I would like you guys to draw a schematic diagram of this one. Okay, so this is already 5 points. And then another question here is, which of these appliances can be operated simultaneously without tripping the circuit breaker? Okay, so you really need to explain it on your paper or on the Microsoft Word. So again, you can do this one on Microsoft Word or via handwritten. All right. So of course, you're going to upload the file or the schematic diagram in the Microsoft Word format. Okay. So are we clear with this one?
Yes.
Yes, sir.
Yes, sir.
Okay, so that's the only question wherein you need to upload the file. Then the rest are just fill in multiple blanks. Okay, so just read the question and then put your answer. Okay, and then some multiple drop downs. So again, situational. If you really understand the concept of resistance, current, and then voltage. So another situational, and then another multiple blanks, and then another schematic wherein you have to answer this, etc., etc. Okay, until question number 10, right, which is in parallel connection. So as you guys can see, this one is super easy. Okay. And for the question 11, okay, so this is now where you're going to submit all of these solutions, okay, of your quiz. So starting from number 1 to number 10, that one must have a solution, okay? So I will be checking your solutions, whether it's really not colliding. It's really, what do you call this one? What is the English of tugma? Ang lalim ng tugma. Your solution and your answer in your solution should be the same with your final answer here. Okay, that's what I want to say. Okay, so be sure that your solution is correct also. Okay, not just the final answer that you're going to put on every blanks or questions. All right, so in total, you're going to submit 2 files. Okay, one for that specific question for number 2, I guess, and question number 11 is the whole solutions. All right, so are we clear with this one?
Yes po.
Okay,
Yes, sir.
so again, just a reminder, just put 2 decimals. Like for example, we have this answer 5.66666, let's say infinite. Okay, just make it 5.67. So you can round it up if necessary. Okay, but get the 2 decimals only. Right, so again, write your complete solution. So no solution, no points. So all of your numbers should have a solution. Okay, So that's it for your quiz. And then later on, I will publish this one once I'm done in finalizing your exercise number 1 and number 8. Okay, so you can also answer this one once this one is available. And what else? Okay, let's see if I added something right here. No, I didn't change anything. Oops. Okay. Right. So yeah, that's it for now for the week 1. So next week will be the module 3 or the continuation of module 2. So we'll see. So any question or clarification so far?
No, sir.
How about the others? Do you guys have a question or clarification?
Sir. Wala naman, sir.
Wala po,
None,
sir.
sir.
All right. So if you guys have a future question or problem, so feel free to message me anytime in my canvas. Okay. Right. So yeah, that's it. So you guys may now go and see you guys next meeting. So thank you guys for coming. I really appreciate it.
Thank you, sir.
Sir.
Thank you din, sir.
Thank you, sir.
Thank you too.
Thank you, sir.
Thank you too.